Welcome back to another video, guys, and today we're going to be discussing slope and two ways to find them, either algebraically or to use an equation, or you can just look at a chart and count the stairs from there. So let's say you had a function of x plus 1, which usually looks like this. Slope is just a definition that at a certain point, it's how steep that line is. So you see how steep this line is? This would be the slope. And obviously, if you're a math nerd, you could already tell that this slope is just 1 because it's just an invisible 1 over the x. But slope is essentially just how steep it is. And it's through a mode called rise over run. So essentially is when you count, you know, how much the function rises and then you count the run. So it's essentially you're going up or down first, then you're counting from left to right. And that's how you find slope if you just look at a chart. Obviously, you have to count some, if you have like a graph like this, obviously you have to count like, let's say you had a slope of like this. Obviously, this is like 1, 2. This 2 would be the run, then 1, 2. So then you could just say 2 over 2 is equal to 1. So then 1 would be your slope. Now, algebraically speaking, I wrote the equation right there. Y2 minus y1 over x2 minus x1, which is what I'll be focusing on today. And so back in 8th grade, this did confuse me for a lot because I didn't know how to add or subtract negative numbers, which is the big thing. But let's just say you had 2 points. Let's say you had those 2 points. Using our equation, we can find the slope from here. And the reason why this equation works is because you're taking it from the rightmost side and then you're subtracting the left point from the individual coordinates. So this will be x and y, then this will be x and y. So now from here, if we use our equation, you'll get 5 minus 1 over 2 minus 1, which is equal to 4 over 1. So our slope is 4. And this makes sense because if you graph it, let's just say this is 1, then this would be 2. You can see how this is really, really steep. And it's way steeper than 1 or 2. You can see how this slope is very, very steep because of the coordinate line. Now, let's move on to another example where sometimes you might get a negative slope. So now, using our equation again, we just do 5 minus 10, then 3 minus 2. And then, obviously, for 5 minus 10, you'll get negative numbers, so it's just negative 5 over 1. So our slope for this one is just negative 5. And again, with the chart, it makes sense. Because let's say you add, let's just say this is 10, and then this is 2. Then you add 3, 5. You could see how this line is going down. And you can see how it's going in this direction, which signifies as negative. negative slope. If it's going like that, it'll mean it's positive. Now, for our third example, let's do some negative numbers. Let's spice it up a little bit. These are just random coordinates. I'm not making any sense of them. Put down an equation again. I should probably start doing this. So then as you can see, we have the coordinates of -1, 5, and then the coordinates of 10, 8. So obviously 8 minus -5 over 10 minus -1. Now, if no one has ever taught you how to subtract a negative number, don't worry, I'll be here. So let's just say that you had 8 minus -5. Well, a negative times a negative is always a positive. Then a negative with a positive is always a negative. Then obviously positive with positive is just positive. So that's just a cool little trick to help you remember the negatives. So from here, we can say that negative times -5 is just +5. So you're really just adding them. So if you want, you can always turn it like this to make it more simpler for you. And you can see how our equation gives us the answer of 13 over 11 as your slope. And once you start getting really good at these, you can start using them for point slope form. See, that's another separate video. But that's just a way to find slope if you're still confused about, finding simple slope problems. Hopefully you enjoyed. Thank you for watching. Goodbye.